Hi! In this video we're going to take a look at the SAT math topic of evaluating functions. So we're going to go over real quickly function notation and a couple examples of evaluating a function, and then I've got 7 problems picked out from the College Board practice SATs that we're going to go over. So let's take a look. Okay, so in function notation, this is read f of x equals 3x plus 2. So we're not multiplying the f and the x. Usually when we have two things next to each other, we're multiplying two things together when they're next to each other. But f simply just names the function. And then x is the variable that we're putting into the function. So x is the input, f is the name. So we would take f of 5 and evaluate that. We would take our function, and then we would put 5 into the function, and then we would just evaluate that. So f of 5 becomes 15 plus 2. Combine those terms and we get f of 5 equals 17. So when we write it like that, it shows us what we put into the function, the 5, and what we get out of the function, which is a 17. Now we can also evaluate a function using an expression. So rather than putting a number into a function, we can actually put an expression into a function. So we wanted to calculate f of x plus 4, then we would take the function and we would put x plus 4 into the function for x. Now notice I put parentheses around it. It's usually best to put parentheses around it because that takes the place of x. So the whole x plus 4 takes place of the x. So we're going to have to multiply the 3 by the x and by the 4 using distribution there. So that'll get us 3x plus 12 plus 2 when we do distribution. Then we combine the 12 and the 2, and we get f of x plus 4 equals 3x plus 14. So now let's take a look at a composite function. So if we have two functions, one is named f and one is named g. F of x is 2x plus 3, g of x is 4x. And if I was to ask you to find the f of g of 2, so this is a composite function. We work from the inside out. So we first have to find g of 2 in order to do this. So g of 2, we take the function g, which is 4x, and we put 2 into it. And then 2 times 4 just gets us 8. So that's just the inside part, the g of 2. So g of 2 equals 8. So now if we take the f of g of 2, now that we've calculated that g of 2 equals 8, we can take and we can put 8 into that function. And then we just simplify the math. 8 times 2 is 16. 16 plus 3 gets us the 19. So that's how we would do a composite function. Okay, so let's take a look at these 7 practice problems from the official practice SATs having to do with evaluating functions. Okay, so the first one, we've got h of x equals 2 to the x, h of 5 minus h of 3. So we're just going to put 5 into the function. So h of 5 is going to be 2 to the 5. h of 3, we're going to put 3 in and get 2 to the 3. And if we just subtract them, we get 2 to the 5 minus 2 to the 3rd, or 32 minus 8, which is 24. So the answer for this is C. Okay, on this problem we're putting in negative 3x for f. So f of x is negative 2x plus 5. So f of negative 3x, let's put negative 3x in parentheses, so we realize that we're multiplying the negative 2 by the whole thing, negative 3x. Negative 2 times negative 3x is going to be positive 6x plus 5. And we get B as our final answer there. So now in this problem, the complication is that we have a constant in here. So we can't just put negative 2 into the function and calculate it right away, we've got to use the fact that they're giving us that f of 6 equals 7. We're going to use that to first calculate the value of b, and then we'll be able to find the f of negative 2. So if f of x is 3/2 x plus b, and that's going to equal 7 when we plug in 6 for x. So 7 equals 3/2 times 6. 2 goes into 6 3 times, so that's going to be 9. Another way to look at that is 18 over 2. 6 times 3 is 18, divided by 2 is 9. Plus b, subtract 9 from both sides, and we get that b equals negative 2. So this becomes 3/2 x minus 2. Now we can put in negative 2 into that function. So f of x, now that we've calculated b, becomes 3/2 x minus 2. So f of negative 2, 3/2 times negative 2 minus 2, which is negative 5. The 3/2 times the negative 2 is negative 3 minus 2, and that gets us the negative 5, or A, as our answer. Now in this problem, I want to show you a couple different ways. So we also have a constant in here, A, that we would have to figure out. But there's also another trick to it. Let's first do that, and then I'll show you a much shorter, easier way to do this one as well. So if we were to put this in, so if we put in 4, the function is going to evaluate to 8. So we could go that 8 equals A times 4 squared plus 24, or 8 equals 16A plus 24. Subtract 24 from each side. Negative 16 equals 16A. So A equals negative 1. Now we can go ahead and put in negative 4 into the function. So g of negative 4 equals, now we calculated A to be negative 1, so it's going to be negative 1 times negative 4 squared plus 24, which equals negative 4 squared is going to be positive 16 times negative 1 is negative 16 plus 24, and we get 8. So our final answer is A. Now, much easier way to do this, however, if we were to notice that we're taking g of 4 and g of negative 4, if we put a number into x squared, since we're squaring it, if we put in 4 and square it, and put in negative 4 and square it, we're going to get the same thing. So g of 4 in this case is going to be the same as g of negative 4. So we know that g of 4 is 8. So g of negative 4 also has to equal 8. So that's another shortcut, much easier way to do this if you recognize that. If not, then just solve for the constant and then go ahead and plug it in and solve for the other, solve with the other function. Either way, we get 8 as our answer A. Okay, so we've got function here, f of x, and then we have f of a equals this. So we've got to figure out what that value of a is. So what we can do is we can take x plus a and put it into this function. So f of x from the first function is 5x squared minus 3. So f of x plus a from this function is going to get us 5 times x plus a squared minus 3. Now in order to multiply x plus a out, we could use FOIL. That's going to get us x squared plus 2ax x plus a squared, so that's just this part here. Multiply that by 5, and then minus 3. Multiply the 5 out, 5x squared plus 10ax plus 5a squared minus 3. So that's from the first equation if we put in x plus a. Now, this second equation, f of x plus a equals this. So then we're going to set these two equal to each other. So what we just calculated was 5x squared plus 10a plus 5a squared minus 3, and that's got to equal this other one, 5x squared plus 30x plus 42. Now we got 5x squared on both sides, so that cancels out. And now, we forgot an x here. Let's just put that in. So now this middle term, 30x, has to be the same as this middle term, which is 10ax. So if 10ax equals 30x, then a is going to equal 3. Now we could have also done it with the constant term as well. So 5a squared, since a is a constant, equals 42. And you can also see if you set these two equal to each other, you would also get the a equals 3. 3 squared is 9. 9 times 5 is 45. Minus 3 is 42. But we don't really only need to do one or the other in order to get our answer for a equals 3, and c is our final answer on that. All right, in this problem, we're dealing with two different functions. So we want to find h of 0. So if we have h of x equals 1 minus g of x, so h of 0 equals 1 minus g of 0. All we did was plug in 0 for x. But now in order to get this, we've got to go and find out what 1 minus g of 0 is. So that we just have to do g of 0, so we just have to put 0 into this. So if g of x is 2x minus 1, then g of 0 is going to be 2 times 0 minus 1, or g of 0 is negative 1. So now h of x equals 1 minus g of x. So let's pull that down here, equals 1 minus g of x, which we just calculated to be negative 1. So that's 1 minus negative 1, and 1 minus negative 1 is the same as 1 plus 1, or 2. So our final answer here is going to be D. All right, and on this final problem, we have compound functions. We got f of g of 3, but we don't have the functions written out themselves. So to get g of 3, let's work from the inside out. So g of 3 is just given to us right here. G of 3 is 2. So this whole thing, f of g of 3, just becomes f of 2, because g of 3 is 2. We can just substitute it in there. And now f of 2. Well, they tell us f of 2 is 3, so f of 2 equals 3. And that's our answer right there for B. So a lot simpler than it actually looks. They don't give us the equations, but we can still use what they've given us to substitute in and get B as our answer. Thanks for watching, and if you have an SAT coming up, good luck. I'm going to continue to add SAT material, so if you'd like to subscribe right up here, you can get notification of when new material comes out, and I've got some more stuff for you to watch right here. Thanks again for watching, and please come back soon.